Welcome to this tutorial on LaneGraph, the powerful road network creation tool for Unity. LaneGraph is designed to help game developers and simulation creators build complex, realistic road networks with precision and flexibility. Whether you're developing a racing game, city simulator, or autonomous vehicle training environment, LaneGraph provides the tools you need to design intricate road systems. With LaneGraph, you can easily create and manage different lane types, build complex intersections, and implement lane transitions like merges and splits. The system is built with both editor convenience and runtime performance in mind. Throughout this tutorial series, I'll show you how to harness these capabilities to create dynamic, responsive road networks that can power your next project. Let's get started with LaneGraph. Firstly, let's download the LaneGraph package from the package manager. Once download has finished, import the LaneGraph package into your project. Next, we need to create lane profile in the project settings. Open the project settings, go to LaneGraph. Click on Add Profile. This profile determines how many lanes you want to have for the single component. You can customize each lane configuration according to your need. I have named this profile 4-way lane consisting of 4 lanes, 2 forward and 2 backward. Now that we have created lane profile, let's go and add lanes in our scene. Click on the hierarchy, go to lane, and click on path lane. I am going to name this component as 4-way lane. Let's reset the transform to keep it in center. Assign the lane profile to 4-way lane that we just created from the project settings. As you can see, we have 4 lanes created to this component. Click on the sphere node to modify the transform however you like. You can change the shape type to Auto Bezier or Bezier to manually control the tangents so that you can have smooth and nice curve formation to your lanes. You can add as many path lanes as you want in your scene and snap the end node points. The tool allows you to automatically snap the endpoints of different lane components if each matches the same set of lanes, its direction, tags, and width of the lane. Let's add in the intersection component. This component allows you to customizable intersections with flexible connection options. You can either disable or enable adaptive tangent to manually control the tangents and how you want the face direction for each node point. Give each node point a name so that you have an idea of which lane's connections can be made with each node point. Once done, let's modify lane connections, the critical part of this component. Click on the specific node under Lane Connections. You can disable or enable each lane between the 2 node points. Note that each node point only has lanes that are starting from. Let's create another lane profile in the project settings. I'm going to name this 3-way lane. You can also assign different lane profiles for each node point. Ensure each assigned profile has at least 1 forward and 1 backward lane to start making intersection connections. Once the necessary lane profile has been assigned, ensure the lane connections are properly updated. By default, the intersection component creates 3 nodes that forms a T-shaped intersection. You can add as many nodes you want for your intersections and update the lane connections. Next off, let's add the transiton components, otherwise known as merge/split component. This component allows you to merge or split the lanes for the assigned lane profile. Adjust the tangents and the node points so that you control how merge or splitting of the lanes can be. Finally, once you have all the lanes set up in the scene, it's time to build the lane graph. Make sure you add this scene into the build settings. Once done, click on Tools, Lane Graph, and select Build Lane Graph. This creates a scriptable object that contains all the lanes data from the scene for runtime access. This is because all the object components added to the scene are editor-only objects, meaning they provide no value at runtime. Ensure you build the lane graph each time when you modify the lanes or deploying an application. Once the lane graph has been built, it's time to initialize the lane graph in script. For additional demonstration purpose, I'm going to show you how to make a 3D game object travel from point A to point B. Make sure you've used LaneGraph namespace to access all the API that helps with querying the lanes. Let's create two transforms point A and point B. Let's create a float for the object movement speed. You can simply initialize by calling the LaneGraph manager and initialize. This initializes the lane graph for the current active scene. Let's say you have the lanes in some other scene. For this, you can simply pass in the scene build index to the initialize function. Now let's get all the lanes that has the connection from point A to point B and cache this in an array. Ensure you handle null check if the path contains lanes between the points. Create and assign the first index as current lane, and let's put our object to the first index of the lane point to start traveling from. Let's create current lane index and current lane point index to keep track of which lane and in which point our current object is positioned. In the update function, let's get the value of the current lane and ensure it's not null or exit the function early. Let's also check if the current lane index or the current lane point index are within their total array length to prevent from getting out of bounds. Let's increment the current lane point index if it reaches the target position, and also increment the current lane index if you have reached the last lane point. You can simply get the current lane by calling getLane and passing the lane index as a parameter. If you are in the last lane index and last lane point index, you have reached the final destination. Now, for the final part, let's get the current object position and the target position of the current lane point. I'm using the move towards function for simple movement from point A to point B. If we've reached the target point, then we increment the lane point index. Now let's create an empty object named LaneGraph in the scene. I'm also going to create two other empty objects as point A and point B. Let's move point A transform to one end and the point B to the other end. Add the script to the LaneGraph test, and for visibility, I'm going to add an 3D cube object as child. That's it. Now you know how to move your vehicle or any object by using lane data. For more API script demonstration, have a look at the example scenes and scripts that is provided in the package. That brings us to the end of our LaneGraph tutorial. To recap, LaneGraph provides a comprehensive solution for lane-based navigation with its intuitive editor tools and optimized runtime APIs. You now have the knowledge to create complex road systems with multiple lane types, design customizable intersections, implement lane transitions, and control traffic signals effectively. Remember these important technical details that make LaneGraph stand out. The system leverages a bounding volume hierarchy, BVH, for extremely efficient spatial queries, ensuring your vehicles can quickly locate and interact with nearby lanes. Lane connections are represented as directed graphs, providing a solid foundation for pathfinding operations. And the implementation of A-star pathfinding delivers optimal route calculations between any 2 points in your road network. I hope this tutorial has been helpful in showing you how LaneGraph can elevate your project. Whether you're developing racing games, city simulators, or autonomous vehicle systems, LaneGraph provides the foundation for realistic and efficient vehicle navigation. Thank you for following along, and I look forward to seeing the amazing road networks you create with LaneGraph.